Good day, guys. How are you doing today? In our previous lecture, we set up an environment that will enable us to carry out the practice of object-oriented programming environment using C++ and C. But in this course, we're going to be looking at object-oriented programming. So let's dive into the course. What is the objects? What is objects? Object-oriented programming. Object can be anything. Object has a state and behavior. Object seeks to represent an idea of a situation. From the object, you can have a behavior and as the state, present state of that object. Let's see the core idea of object-oriented programming. Programming language is a paradigm that centers around objects. Objects encapsulate data and code. Our data can be represented in the form of attributes and properties. Then that means it can be our fields. Our code can be methods or procedures or functions that operate on the data. Let's see the primary goal. The main primary goal of OOP is manage software complexity by modeling real-world or abstract concepts as self-contained interactive units. Let's see the benefit of OOP. OOP is self-contained object, aid in troubleshooting and collaborations. OOP also enables us in code reusability through the help of inheritance and polymorphisms. We also see maintainability and scalability for easy updates and well-defined interface. Also flexibility through the help of polymorphism, the system be able to adapt appear in many forms. So also for real-world modeling, what are the drawbacks that we also face in object-oriented programming? Can be less performant than procedural programming language, because yes, an example of them is C and Pascal. There's an example of a procedural programming language. Complexity, steeper learning curve that can also appear in object-oriented programming language. You can also have risk of creating over complex design. You can see, let's just suppose between object-oriented programming and procedural programming languages. Let's see some of the focuses. The focus of these two instructions start functions. We know that software is made up of instructions. It's made up of programs, and programs are made up of instructions, and instructions are made up of commands. Let's see instructions. Let's see the distinction between the two of them. We can see that also the fundamental unit was functions and procedure, but in object-oriented programming OOP, we are seeing object and classes or classes. Let's see the data handling, the way they handle data. It often separates from functions, but this one is bundled with objects. But let's see the data security. Lower. Let's see the data security is very lower, but in the other side is higher encapsulation. Higher encapsulation enables for data hiding. Let's see reusability. We also see functions and libraries. On that side, we also see inheritance and compositions. So modularity enables to modularize our code. Unlike Go and Rust, we also see that there are also in procedural programming language, also system programming languages that make use of procedures. Procedures can be one form of functions based. Also, let's see the concept. This one is based on the function variables. The other OOP focus on classes and objects. The example of them, you will have C, Pascal, and Fortran. Example of procedural programming languages. But in C++, in object-oriented programming, example of it is C++, Java, Python, and C#. So any programming languages that make use of classes are regarded to be object-oriented programming. But sometimes also Python programming languages is considered to be object-oriented programming because it also makes use of of classes. So also as PHP, other programming languages as well. Later on, we can also consider Python to be also as part of the scripted programming languages. But let's see the pillars of OOP. What are those things that make up OOP? What are those things that are common among OOPs? Number one, then we have classes and objects. Classes are what are the templates, a blueprint for an object. Template means the template, from template you can create something from a template. So that's when you can create objects from a template, from a class. We create objects from classes. So a person can be a class. A person can have both state and behavior, can have both our data and code, our functions. A behavior can be in form of functions and method. Its eating, its movement can change also, as well as but some of the things cannot change about the person. Maybe the color, the number of hand that he has, the number of leg, the number of what maybe for also a car, the number of doors the car has, the brand, the engine name, the engine type. So those things also can be in form of state that cannot change. But the thing that can change about it, the mood, the speed, the movement, understand? Also stop, you apply brake. So those things are also changed. Also look at encapsulation for data hiding, for data security. Also look at abstractions, hiding the complexity of the code, hiding the complexity, but representing them in form of simple forms. Also look at inheritance. It enables us in code reusability. For example, you can, instead of rewriting a bunch of code, you can also inherit some of the code we have already written by just changing some of the things, or reuse the same code the way it is. Also, we have polymorphism, something appearing in many forms. Example, can also achieve polymorphism through maybe function overloading. We are going to be seeing all these things as we progress in this course, or function overloading or constructor overloading as well. For this example of a class, you want to create a class in C programming, in C++ program. You can just create you can create, let's open our VS Code. You can just open. Yes, this is from our former classes. Now let's try. Let me try and let's create a file. Let's just assume, let's create a folder called new OOP. Let's just call it new OOP. Then from this new OOP, let's call it maybe P1, maybe part 1 of this course. Part 1, maybe P1.cc or .c++. Then we have it this way. Then we can have what this is class, this is object, it can be anything. For example, this is dog, and this is the name, you end with semicolon here. This is a what? This is a class. This is a dog. The name of this class is called dog. So this is the body of the everything here, inside here is the body. We write our code here. Everything inside this class is the what is the body of the class member of dog. So here we can have what the breed, the int breed as shown in our code here. And has here is represented what? What? Public. That is our specifier. We talk about it later. We want to make it so that it can appear even up from other classes, in other classes. Can have strings, can name the name of the dog, strings, the int age. These are integer types. These are int. You do not read about data types. So you can also consider our C programming languages. We talk about data types. We talk about data type and string and int as well. Then this is class dog void break. Now let's see. For example, for me to use I can't use string like this here. It's not fun. I still need to import some other things that will enable me to do that. And what are those things? There are some things I need to include in my language. I include. We use the keyword include with pans include. IO stream enables us to perform input output stream. There's still other things we also need to do. If we don't do that, For example, if we also demonstrate what is written in the slide here, std, you can see std string. You can also do the same thing here. std, that means standard. So we can also find our string here. Then we now name it as what? Maybe the breed of the dog. So, okay, maybe the breed is from which breed? The German Shepherd, is the Australian Shepherd. So you can see the breed of it. Integer is what? Int age, right? But you can mistake it because in this can also take a negative number. You can just put unsigned in front of it. That means we don't expect negative value from this integer. Unsigned. Sorry, unsigned int age. And that means it can only take a what? A positive integer. Then you can also have our functions. Remember that we put what? Have a public specifier to tell you that, oh, this thing can be public. You can access them later on, and when we even leave the class. This public tells us that we can still access this variable later on and access value to them. For example, if I come and just declare our main class here, int main. Sorry, int main. So that means, remember, this function is int here. We have to return, for example, let's just return something 0. So returning not, just returning 0. Then if you create an object, we want to create an object for this class now. So from this class dog, this is dog. Then let's create a class for it, or an object for it. We say it's a template. We have a template for creating different type of dogs, whether it is Australian Shepherd or German Shepherd. So we can create it here, right? From this is a template now. It's called it a blueprint or template for creating an object. This is dog. Dog, maybe this is dog one, right? This dog one now. Can you see? I can easily say, you can use call it name dog one dot. Can you see breed? I'm able to access these things because I make it public here. But if I remove the public class, and I won't be able to access them. Can you see? Say member, not breed. It's a member dog breed. Said declare at line 6 is inaccessible. You're going to point that. It's saying that I've declared something here. It's inaccessible. So I'm going to fix, or I'm going to talk about more of this later on as we proceed in our code. We are talking about, we have an object now. We also call it an instance of a class. It's an instance. That means it's an object. You call it an object, you call it all an instance. So let's look at it. Also, it owns its own state and values of the data members. You can see we assign it to here we call what Labrador. We also give it the word Labrador here. We can also do the same thing, quite the same code. Let's look at encapsulation. I see bonding or unhiding. Bonding data, attributes, and method functions that operate on the data into a single unit of class. Crucially involve data hiding. It enables, I'm going to demonstrate a sample of this much for us in later on as we progress. So just because we talk about the data pillar of OOP, just need to mention what it does here. For data protection, for the control access via access specifier. Like this now that we're unable to do here, we're able to achieve it through the use of encapsulation. I'm going to demonstrate it for us through the use of setter and getter method, so that we are going to work for all we should not have access to all this our data this way, because it is make our code unsecure. But we are going to use through the help of encapsulation. We are going to have an access to them later on. So then we have it here. For example, we have a bank account. We have a private here. The balance. Nobody should not have access to it. But through the use of encapsulation, we are able to get it done. I want to explain this code later. We're going to see an example, try some code about this later on. So you may not understand them now, but that's how encapsulation works. Let's look at what are abstractions. Abstraction, hiding complex information details and showing only the essential features. Focus on the what, not the how. So let's see the purpose for simplicities. Users interact at higher level. Isolation. Internal changes don't affect users in the interface table. You can focus on what you can see. You are going to demonstrate a sample of this. For example, we have shape. We can also implement them for different form of shape that we have. You will have a shape called class shape. shape here, a class called shape here. We have a public functions called visual. I'm going to explain this thing later on. Don't allow me to also have the structure here. Don't allow me to go into details about this. Then also have inheritance, also that also enables us to inherit code through the above superclasses. Polymorphisms also coming in many forms, appearing in many forms. Let's also see static combined time polymorphism and runtime polymorphisms. So we will see a sample of these as we progress in the slide. So let's see the summary. Said we look at the powerful paradigms. We OOP as a powerful paradigms. We look at it as we provide a structured approach to software development, facilitating modularity, reusability, maintainability, and scalability. So what is the key takeaway we are seeing here? Mapping the concept of classes, objects, and abstractions, inheritance polymorphism is essential for leveraging OOP benefits, managing complexity, and building robust software languages like C++, Java, C#, and Python, etc. So thank you very much for listening. So we get more into examples in our second lectures. Just like, share, subscribe. Bye-bye.